Okay, we just finished talking about the heart physiology in our last video, and now we're going to go over the action potentials within the heart. Last time we left off by kind of hinting at this little orange dot called the SA node. Now I'm going to draw a line all the way out here. All right, the sinoatrial node. This is what starts every single action potential. This is also called the pacemaker. We are going to compare this to a standard action potential. So we can say here, just standard. So this is just what happens in all muscles and stuff like that to generate an action potential. We're going to compare the difference between the graphs and the different ion concentrations of different phases of these different potentials. Normal action potential looks a little something like this, whereas the SA node looks a little something like this. You can label these. This is going to be phase 0, phase 1, phase 2, phase 3, and phase 4. Now over here, we're going to label this one phase 4, up here, phase 0, and then phase 3. All right. Let's start with the standard action potential, and then we'll move to how it's modified in the SA node. So phase 0, this is going to be when Na channels open. As we can see, this is depolarization. So phase 0, Na channels open, action potential spikes up. So initiate depolarization. All right, now we have phase 1. This is when we start to dip back down, and this is due to potassium channels opening. So these K channels are opening, and then we have a little bit of a plateau at phase 2. Now here, the K channels are still open, but the voltage gated calcium channels are also open. So this is our plateau phase. That is due to calcium. Now phase 3, we're completely repolarizing, and this is due to just the K, the potassium channels being open. So the calcium channels are no longer open. It is only the potassium. And then phase 4 is just resting, all closed. All right, now let's take a step back and think about this. An action potential is generated by sodium channels opening. So these Na channels is what initially depolarizes the cell. So at phase 0, the sodium channels open. That causes a spike in the potential, which is called depolarization. Now, to get it back down, potassium channels open. So potassium's channels start to open, and then calcium channels also open, which makes it plateau a little. And then when the calcium channels close and it's just potassium open again, it goes back down. And we can see a little dip here between phase 3 and 4. That is called hyperpolarization. That happens because the K channels are open for a while, and then eventually it evens back out due to the Na-K ATPase pump, 3 Na out, 2 K in. It brings it back to that equilibrium. So that is a standard action potential. Now let's move over to the SA node. If we notice, we only have phase 4, 0, and 3. Phase 4, similar to standard action potential, it's going to be these sodium channels. So they're going to leak until threshold, which is similar to the regular action potential. We didn't mention it earlier, but the sodium channels have to reach a certain threshold before full action potential can be depolarized. So phase 1 is pretty much the same. It's a little bit, it's not quite as steep. Now phase 0, this is due to purely calcium channels. So that is the big difference. So this is voltage gated calcium channels open. So this is just calcium channels. And then lastly, our phase 3 is going to be those potassium leak channels that makes it hyperpolarized. So K plus leak channel makes it hyperpolarized the same way as the potassium channels make it hyperpolarized in the standard action potential, just this time it's a lot more simple. In the SA node, it's really sodium, calcium, potassium. In the standard action potential, it's a little different because it's sodium, potassium, calcium, potassium. Again, that is really it for the action potentials. It's not too much, but just knowing what ions cause depolarization, cause hyperpolarization, stuff like that is very important. I'm going to highlight the key terms in this before I upload it to the link tree, but this completed note set will be in the link tree. It will be under biology notes, and it will be under action potentials. So yeah, that's all I have for you.